Welcome to qnawire.
In this problem, we need to solve for the height to which gymnast B will rise when gymnast A is the one that jumps onto the plank. So I have here a sketch of the problem. So gymnast A with mass MA jumps and falls from a height h and strikes point E with a velocity v1. So this causes the plank to rotate with angular velocity omega and point E to move with a velocity VE downward and point C to move with a velocity VC upward. So this sends gymnast B off into the air. So let's write first our given values. So we're given the masses of the gymnast A, gymnast B, as well as the mass of the plank. So MA is equal to 55 kilograms. So this is the mass of gymnast A. And then MB, mass of gymnast B, 70 kilograms. And then MP is the mass of the plank, 15 kilograms. Okay, so let's start first with some initial calculations. So the moment of inertia of the plank, given its shape, is given by, so I equals, so 1 over 12, the mass of the plank, times the length of the plank, which is equal to 2L. So that would be 2L squared. So the moment of inertia is equal to 1/3 mass of the plank L squared. We can also calculate already the velocity at which the gymnast strikes the plank. So this would be our V1. So since gymnast B sort of fell on the plank after he jumped at the height h, so the velocity v1, so which is his final velocity, can be calculated using the equation. So v1 equals square root of 2gh. So that would be, so 2 times 9.8 meters per second squared times h, which is 2.5 meters. So this is equal to 7 meters per second. Now, since the linear velocities can be expressed in terms of r and omega, so we have vc and ve. So vc is equal to L omega, since point C is at the distance of L from point D, which is the point of rotation. And then VE is also equal to L omega, because again, point E is at the distance of L from point D. Now, solving for the moments about point D, taking the counterclockwise direction as positive, so we'll have the equation, so M E V1 L plus 0 equals M E V E L plus MC VC L, then plus I omega. So substituting our expression or equation for VC, for VE, and for I, which we have written earlier, so this will become, so M E V1L equals, so M E L squared omega plus MC L squared omega plus 1/3 MP L squared omega. So simplifying this, so we get, so M E V1L equals, so let's factor out omega, so omega times ME L squared plus MC L squared plus 1/3 MP L squared. So, solving for omega, so we'll see that omega is equal to, so ME V1 all over, so L times, so ME plus MC plus 1/3 MP. There, so that's our expression for omega. Now, when the end of the plank, which is the point C, rises as a result of the impact of the gymnast B, so it will send gymnast A, again, off, flying into the air. So with a velocity VC, directed upward. So, since at the maximum height, the velocity is 0, so because what we're actually getting here is the maximum height. So since at the maximum height, the velocity is 0, and VC is sort of our initial velocity here, so we can get, or the equation for VC would be, so VC VC is equal to square root of 2G HC, where HC is the height reached by gymnast A. So, since we now have an expression for omega, we can now solve for VC. So, VC, using our equation earlier, VC equals L omega. So, we can replace omega with our expression earlier. So, this would be, so L times MEV1 over L times ME plus MC plus 1/3 MP. So, of course, this will cancel out the L. And note that ME here is equal to MA, so which is the mass of gymnast A, and MC is equal to MB, which is the mass of gymnast B. So, VC would be equal to, so 55 kilograms times V1, which is 7 meters per second, all over, so 55 kilograms plus 70 kilograms plus 1/3 of the mass of the plank, which is 15 kilograms. So, this is equal to 2.9615 meters per second. Now, so solving for HC, so HC is equal to, so VC squared over 2G, so that would be 2.9615 meters per second squared over 2 times 9.8 meters per second squared. So this would give us 0.447 meter.